Having dealt with atomic number 60, we're now moving on to atomic mass 60. This is a little more complicated. There are three elements that have isotopes of atomic mass 60: cobalt, copper and nickel. Of these though, nickel is the only one where the isotope with a mass of 60 is stable, so we'll focus on that one. Have you ever wondered why transition metal compounds are usually coloured? If so, or even if you haven't, it's all to do with the fact that they have partially filled d orbitals. In the metal atoms, all the d orbitals have the same energy. However, when ligands bind to the metals, the d orbitals are split into two different energy levels. When visible light is shone on a sample of a transition metal complex, some of the electrons in the ground state absorb energy from the light and are promoted to the excited state. The wavelength of light that causes this change, corresponding to photons of a particular energy, is absorbed, and this affects the overall colours that are reflected and hence observed. The degree of splitting, and hence the energy gap and the colour, is affected by the ligand as well as the metal itself. Here you can see the familiar blue of copper ions in solution. These are complexed with water molecules. If however you add chloride ions, these displace some of the water ligands and you get a green solution. A nice example of this phenomenon uses a solution of nickel sulfate in this case, and it complexes with 1,2-diaminoethane, also called diethylamine. This is a bidentate ligand, meaning it has two binding sites. Initially, as you can see, all the solutions are green. This is due to the presence of 6 water molecules acting as ligands around the nickel. Adding a small amount of 1,2-diaminoethane causes one molecule of it to displace 2 of the water molecules, producing a pale blue complex. Adding a bit more displaces 2 further water molecules with another 1,2-diaminoethane, producing a darker blue complex. And finally, if you add enough, all the water is displaced and all the ligand sites are occupied with diaminoethane, producing a nice purple solution. If you are concerned about using nickel, then similar results, though less impressive, can be obtained with copper. And of course there are numerous other reactions you can do with transition metals and a whole variety of ligands.